Welcome to How to Consume MRN Data with Elektron WebSocket API video. This video will give you an idea of how to implement a WebSocket application to consume and decode Refinitiv MRN data. Firstly, please let me introduce what the MRN is. The MRN or Refinitiv Machine Readable News provide deep historical archive, ultra-low latency real-time news and analytics for applications via Elektron platform using open message model. The service aims for replacing the legacy New2K service. The MRN content data is compressed and split into multiple fragments across multiple update messages. This process helps MRN data to be highly optimized for data distribution by reducing the bandwidth and message size. What is the Elektron WebSocket API? The Elektron WebSocket API is a server-side API run directly on your Thread or Elektron real-time in cloud. The API uses a standard WebSocket connection and readable JSON message format, so it supports various programming languages that support the protocol and JSON message. The Elektron WebSocket API can consume and decode MRN data from Elektron. The fragment data in the WebSocket connection is in base64 ASCII string format. For more detail regarding the Elektron WebSocket API, please refer to Developer Portal website. One thing you need to be noticed is the MRN refresh response message does not contain any news data. The application can just ignore the MRN refresh message or print it in the console for informational purpose. All news data fields are available in update response messages. There are 5 mandatory fields that require to process MRN data. The first one is MRN source field, which gives you a new source identifier. Next is the UID field, which is a unique identifier for the news item. Next is fragment field. It contains a compressed data item fragment. Then the total size field. This field is a total size in bytes of the completed fragment data. And the last one is FRAGNUM field. It is a sequence number of fragments for the same news. The main concept for processing MRN data is the application keeps checking the decoded fragment field byte length until it equals to the total size field value. If they are equals, it means this new item is completed. The application can unzip the decoded fragment to get the JSON news message. If not equals, the application waits for the next fragments from subsequent update of this new item. You can find a step-by-step document in Developer Portal website MRN article. Next, I will show you a brief step-by-step code in Python. The first step is the application gets mandatory fields from the update message. You can see that the application uses Python base64 module to decode the fragment field. Next, check the FRAGNUM value. If the FRAGNUM value is equal to 1, it means this is the first fragment of this new item. The application can compare the decoded fragment byte length with the total size field value. If they are equal, it means this new item is complete. If they are not equal, the application keeps this news in the object and then wait for the next fragment from the subsequent updates of this new item. Next, if the FRAGNUM value is greater than 1, it means this is a subsequent fragment. The application gets previous fragments of the same news from an object, then merge it with an incoming decoded fragment before compares a current fragment byte length with a total size field value. Please note that all update messages for the same news must have the same UID and MRN source field value, and the FRAGNUM value must be ordered. Once the fragment is completed, the application can use Satellite module to unzip the decode fragment. After unzip a completed fragment, you will get the news data in UTF-8 encoded JSON message format. Please refer to the MRN data model document in Developer Portal website for more detail regarding the MRN JSON message structure. Next, let me show you the MRN Elektron WebSocket API demo application. In order to run the demo applications, you need the trap server with MRN service. You can contact your market data team or Refinitiv representative to help you on this. You can download all example source codes from GitHub page. The first example is in Jupyter Notebook and Python language. This example gives you a completed code and document for the MRN and Elektron WebSocket API interaction. This notebook lets you follow through each notebook cells for reading the document, modify the source code, and then run it instantly to see the MRN data results. You can configure the ADS server hostname and the WebSocket port here. This cell shows the supported MRN item names and how to send MRN request message to ADS. This cell is a document regarding how to process the MRN data in the update messages. This cell is an actual source code that processes the MRN data from Elektron WebSocket API updates messages. It's implemented based on the above cells document. These cells contain all Elektron WebSocket API JSON process function. This cell is a WebSocket operation source code. The MRN data will be streaming and shows result in this cell. This notebook also covers some of real-time news data model programming guide. You can see how to get each new property from this notebook. This cell shows how to get news headline and story from MRN JSON messages. The next example is a web application using JavaScript. This web application consumes and decodes MRN data with JavaScript language and display news items in the web browser. These web applications connect and consume MRN data from Elektron WebSocket API. It shows a streaming news headline in the top panel. And when you click at the headline, it will show an associated news story in the bottom panel. This example shows that you can build a complex GUI application for displaying news data with MRN and Elektron WebSocket API. That's all for the MRN data with Elektron WebSocket API. You can find more information regarding the MRN data development and Elektron WebSocket API in developer.refinitiv.com website.